Dear students, today we are going to discuss a new topic, that is X-ray diffraction by crystals. Okay, this is a very important topic in solids. So before understanding X-ray diffraction by crystals, let us define and understand the concept of diffraction. So what is diffraction? Okay, diffraction is a phenomenon that we have studied in physics, and we have encountered this phenomena in our day-to-day life. Okay, for example, let me give a rather an example which is outside our general example. Suppose if you are in a room, okay, with a door, and there is one more room adjacent to it, so both the rooms are sharing a common door. And if one person is here, okay, one person is here standing here, and if he has a torch in his hand, and if he switches the light, okay, he has a source of light, and if he switches the light, let us assume that both the rooms are very dark. If he switches the light, okay, the light moves in straight line, and you can see a bright region on one corner of the room and nowhere else. The other portion of the room will be dark. Only one portion of the room where this light falls will be very bright. So this suggests that light is moving in straight line. But suppose, say for example, this is person A. There is one more person in the room, adjacent room. Let us call him as person B. If person A speaks, okay, information in the form of sound wave will propagate, and we know that this sound wave will not only propagate in straight line, it also gets bent at the edges of the door. How do we know that? How do we confirm it, that sound waves gets bent at the edges of the door? Of course, the person B can listen to what person A speaks. So this demonstrates that there is bending of sound wave at the corner of this room. So this phenomenon of bending of light, or bending of wave, I would rather say bending of a wave near edges or corners of an object is called as diffraction. Now, immediately a question arises, a doubt arises in our mind. Light is a wave, sound is also a wave. So, in that case, why sound has undergone diffraction, that is bending, whereas light has not undergone diffraction? Because diffraction is a phenomenon that is associated with wave nature. Okay, it is a phenomenon which could be explained only by wave nature. And as both light and sound are both waves, one should expect diffraction to be observed both for wave as well as light. So the question arises, why light does not bend whereas sound bends? Okay, the answer to this question is, here there is an important condition that one has to satisfy. So what is the condition under which we observe diffraction? So what is the condition for diffraction? And the important condition for diffraction to take place, or for us to observe diffraction, is the wavelength of the wave should be approximately or roughly same as the dimension of the object with which it is interacting. So this is a very important condition. Please remember this condition. We will be using this condition when we discuss X-ray diffraction by crystals. So diffraction ಆಗಬೇಕಾದ್ರೆ ಈ ಕಂಡೀಷನ್ ಕಂಪಲ್ಸರಿಲಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಲೇಬೇಕು. ಏನದು? ದಿ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದಿ ವೇವ್ ಶುಡ್ ಬಿ ರಫ್ಲಿ ಈಕ್ವಲ್ ಟು ದ್ಯಾಟ್ ಆಫ್ ದಿ ಸೈಜ್ ಆಫ್ ದಿ ಆಬ್ಜೆಕ್ಟ್. ಸೊ ನಾನೀಗ ಕೊಟ್ಟಿರುವಂಥ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಸೌಂಡ್ ವೇವ್ ಲೆಂತ್ ಆಫ್ a sound wave is much greater than wavelength of light. Okay, wavelength of light is very small. Wavelength of the light, okay, if you take visible light, okay, wavelength of visible light is in the order of 400 to 800 nanometer, and this is very small compared to the size of the object. Illi diffracting object yaudu? It is nothing but the door or the edge of the door. Okay, so edge of the door ನೀವು ಮೀಟರ್ ಅಲ್ಲಿ ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ wavelength of light is nearly 10 to the power minus 9 meter. So they are nowhere comparable in size. So wavelength of light is very small compared to the edge of the door, whereas the wavelength of sound wave is somewhat closer to the size of the door. So it is sound wave which satisfies the diffraction condition here, and we can observe diffraction of sound wave. There is bending of sound wave. So when person A speaks, it could be listened by person B, but when this person A switches on the light will not bend and it will not uh, uh, follow this trajectory. Light will move in straight line because there is no diffraction of light. However, we can observe diffraction by using light. But what is the necessity? What is the necessary condition under which we can observe diffraction? Of course, we can observe diffraction from light, but we have to reduce the size of the object roughly to the wavelength of light. For that, if you remember, you had used an optical grating. Okay, when you studied physics in your PU class, your teacher might have demonstrated the diffraction pattern, okay, by using an optical grating. So optical grating is nothing but an optical material, okay, optical material in which we have scratched lines. Okay, we have drawn lines by using a very sharp material, very strong material such as diamond. Okay, ಅದರ ಮೇಲೆ lines scratch ಮಾಡಿದ್ದೇವೆ, and each line on the diffraction on this optical grating acts as a diffracting object, and the distance between the two neighboring lines is roughly around 1000 or 10,000 angstroms. They are very close to each other. Okay, so the distance between them is roughly near to angstroms, okay, which is roughly very close to the wavelength of light. So one could observe diffraction of light by using optical grating. Okay, so diffraction takes place both with light as well as sound wave, but under different circumstances. Okay, ಯಾವಾಗ ಈ condition satisfy ಆಗ್ತದೆ, then only we can observe diffraction. Now in spectroscopy class in your physics, okay, what you had done is you had kept an optical grating. This is the top view. Okay, you have kept an optical grating and you had used a light of known wavelength lambda. Okay, and there are many lines on this optical grating. Diffraction takes place and there will be bending of light in different direction. There will be bending of light in different direction. Now if there is a screen, okay, now this line, all these wave packets will interfere with each other. Okay, so there are two phenomena taking place here. One is bending of light, which is diffraction, and the diffracted lights will interfere with each other and they will form a series of bright and dark spot, which is called as diffraction pattern. So diffraction pattern that is obtained here is a result of two phenomena. First is diffraction, which takes place near to this optical grating, followed by interference, okay, mixing up of or superposition of diffracted waves. Both together result in this diffraction pattern. And the nature of the diffraction pattern, what do I mean when I say nature of diffraction pattern? Nature of diffraction pattern ಅಂದ್ರೆ ಎರಡು ಲೈನ್ಸ್ ಮಧ್ಯೆ ಇರುವಂತಹ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿದೆ, okay, what is the intensity of each line, okay, each line, it may be dark line or the bright line, ಇದೆಲ್ಲನೂ nature of diffraction pattern ಅಂತ ಕರೀತೇನೆ. So the nature of the diffraction pattern depends on the nature of the optical grating. Okay, this is very very important. So if I change the optical grating, ಈ optical grating ಬಂದು ಮತ್ತೊಂದು optical grating ಯೂಸ್ ಮಾಡಿದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, where the distance between the lines is different. Okay, ಮೊದಲು ಯೂಸ್ ಮಾಡಿರುವಂತ optical grating ಇಗೂ ಈಗ ಯೂಸ್ ಮಾಡ್ತಿರೋ optical grating ಇಗೂ ಡಿಫರೆನ್ಸ್ ಏನು? The distance of separation between the lines in the optical grating is different. So when the distance between lines changes, automatically diffraction pattern also changes. So ಏನು ಹೇಳ್ಬೋದು ಅಂತ ಹೇಳಿದ್ರೆ, ಈ diffraction pattern ಏನಿದೆ, it is a fingerprint pattern. ಅಂದ್ರೆ depending on the nature of optical grating, you get a particular pattern. If I change the optical grating, diffraction pattern also changes. So this is like a fingerprint. It is unique for a particular optical grating. If the distance between lines in the optical grating changes, the diffraction pattern also changes. So ಇದರಿಂದ ನಾವು ಏನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ತೇವೆ ಅಂದ್ರೆ, ಸ್ಟಡಿಂಗ್ ದಿ ಡಿಫ್ರಾಕ್ಷನ್ ಪ್ಯಾಟರ್ನ್ ಅಂದ್ರೆ ಎರಡು ಲೈನ್ಸ್ ಮಧ್ಯೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ, ವಾಟ್ ಈಸ್ ದಿ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ಈಚ್ ಲೈನ್, ಇದನ್ನು ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದಿಸ್ ಆಪ್ಟಿಕಲ್ ಗ್ರೇಟಿಂಗ್. ಇದು ಆಪ್ಟಿಕಲ್ ಗ್ರೇಟಿಂಗ್ ಅಲ್ಲಿರುವಂಥ ಲೈನ್ಸ್ ಯಾವ ರೀತಿ ಸಪರೇಟ್ ಆಗಿದೆ ಅದೆಲ್ಲನೂ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೋದು. ಓಕೆ, ವಿತ್ ದಿಸ್ ನಾಲೆಜ್ now let us go to the our main topic, that is X-ray diffraction by crystals. Okay, optical grating, why it acts as a diffraction material? Because these lines are very close to each other and they are separated by a systematic way, and the distance between the first two lines in the same distance is maintained between the next two lines, same distance is maintained here, same distance is maintained here. So the lines between any two adjacent, the distance between any two adjacent line is same. So there is a systematic, regular, periodic arrangement of lines in the optical grating, and this is responsible for it to behave like a diffraction material. And this gives a clue here, because what is a crystal? In my earlier video I had defined crystal. Crystal is nothing but regular, periodic, three-dimensional arrangement of lattice points, which may be an atom, molecule or an ion. So crystal is nothing but regular, periodic, systematic, three-dimensional arrangement of lattice points. So similar to an optical grating where there is a regular two-dimensional systematic arrangement of lines, well separated lines, there is a similar behavior observed in a crystal. But the only thing is, in crystal it is not a two-dimensional regular arrangement, it is a three-dimensional regular arrangement. So this makes or gives us an opinion that crystal can also behave like a diffraction material. Just like optical grating, crystal can also behave like a diffraction material. Okay, let me write. So crystal can also behave like a diffraction material. Okay, and this is a very important observation. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಹೇಳಿದ್ದೇನೆ, the nature of diffraction pattern depends on the arrangement of lines in the optical grating. Okay, so by studying the diffraction pattern we can indirectly study the arrangement of lines in the optical grating. So if I replace this optical grating by a crystal, okay, I will replace the optical grating by a crystal, and I will pass a light of suitable wavelength. Since crystal also behaves like a diffraction material, okay, so the light is diffracted in all the direction, you will get diffraction pattern. So by studying the diffraction pattern, you can study the arrangement of atoms or molecules in the crystal, or indirectly or directly you can study what is the crystal structure. Okay, so let me write: study of diffraction pattern of a crystal gives information about the arrangement of lattice points, that is atoms or molecules or ions in a crystal. It gives us not only the arrangement, it also tells us the type of atoms, molecules or ions in the crystal. Okay, so by studying the diffraction pattern, we get two information. One is nature of the atoms, molecules or ions, and their arrangement inside a crystal. Altogether, what information we are getting is the entire crystal structure. So if we want to study the crystal structure, we have to study the diffraction pattern. It is not easy, as I say, there are a lot of mathematical equations involved, but we will simplify and discuss only some aspects that are required to be covered in the syllabus. Okay, so I hope you have understood the significance of this discussion, why we are interested in diffraction by crystals, to study the crystal structure. But the question is, an optical grating diffracts visible light whose wavelength is 400 to 800 nanometer. What about X-rays? Sorry, what about crystals? Do they diffract visible light? To answer this question, we have to go back to the condition for diffraction. The condition for diffraction is the wavelength of the wave. Okay, the wavelength of the wave should be approximately same as the size of the object. Okay, so in a crystal, okay, let me draw a crystal here. These are lattice points which may be atoms or molecules. So crystal is nothing but a regular three-dimensional systematic arrangement of lattice points, that is atoms, molecules or ions in three directions. Similarly, you have different direction. Okay, so this is a crystal where there is systematic arrangement of lattice points. Okay, now which light is diffracted by crystals is decided by the distance between the lattice points. So this is the clue for getting the answer. So wavelength of the light should match the distance between the objects in the crystal, and the distance generally the distance between lattice points in a crystal is roughly of the order 1 angstrom. Okay, this is rough. The distance between the lattice points, that is atoms, molecules or ions in a crystal, is roughly 1 angstrom. Therefore, light of wavelength approximately 1 angstrom will be diffracted by crystals. So as per the condition for diffraction, in order to get a diffraction pattern from a crystal, we have to use light whose wavelength is roughly 1 angstrom. And which light falls in this region? It is X-rays. Okay, so we cannot observe diffraction pattern with visible light in crystals, we are only possible to get X-ray diffraction. X-ray diffraction from crystals. Okay, so let us go into a brief understanding of the theory of X-ray diffraction. I hope you understood the introduction part, the concept of X-ray diffraction. Now let us go into the theory of X-ray diffraction. Okay, historically there are two theories or two approaches. Okay, one approach given by Lave. Okay, another was given by Braggs. Okay, father and son, L.H. Bragg and L.W. Bragg, they together gave a theory of X-ray diffraction. There are two approaches. One is called as Lave approach, another is called as Bragg's approach. Lave approach is actually the correct approach. Okay, whereas Bragg's approach is not the correct approach. It is only an abstract and it is not the correct approach of X-ray diffraction. But due to some reason, why? Because Lave's approach is very difficult. Mathematically, it is very difficult to treat Lave's approach, and also it is very difficult to visualize or imagine the diffraction by Lave's approach. We resort or we uh, depend on the Bragg's approach, which is very easy to understand. Even though it is not the correct approach, it is very easy to understand, and it is very easy also to visualize the process by this approach. Okay, scientifically this is not correct, but though we are using this because the results obtained by Bragg's approach is same as the experimental result. Okay, so that is the reason why we are using Bragg's approach. So what is this Bragg's approach? Okay, so that is the topic of today's video, Bragg's law or Bragg's equation. We'll continue this in the next video.